Today we're going to cover rhombuses. The objectives for today is to know the characteristics of a rhombus and solve proofs on rhombuses. Theorem: every rhombus is a parallelogram. So if we have a rhombus, we know the opposite sides are parallel. Here's an explanation of that. We would say that the two triangles are congruent by side, side, side. They share side AC. So we would say triangle ABC is congruent to triangle CDA by side, side, side. Then, as Shatis said, we have congruent angles by CP. For example, we could say BAC is congruent to DCA by CP. So angle BAC is congruent to angle DCA by CP. What does that do for us, Shatis?
We can say that the two lines are parallel.
Why?
So that interior angle.
Right, we would say AB is parallel to CD by AIA, and since AEB and CD are both congruent and parallel, what does that tell me? Somebody else. Since AB and CD are both congruent and parallel, what does that mean? What's that a characteristic of? Yeah. Yeah, that's a characteristic of a parallelogram. One pair of opposite sides are parallel and congruent. So we could say, in the end, we could say ABCD is a parallelogram. Okay, questions on that? Does everybody have it? Okay. Because we have shown that every rhombus is a parallelogram, we can conclude that all the theorems about parallelograms apply to rhombuses. So, those theorems are: the diagonals of a rhombus bisect each other, the opposite angles of a rhombus are congruent, the diagonal of a rhombus forms two congruent triangles. Same characteristics that we had for parallelograms. Theorem: the diagonals of a rhombus are perpendicular to each other. So if ABCD is a rhombus, we know that AC is perpendicular to BD. How do I know that? How can I show this? Okay. Well, we know the diagonals of a rhombus are bisect each other, right? So I could say that these two lines are congruent and these two lines are congruent. All right? So, now what could I do? Chris?
We could say the two triangles that were made on
Why?
the sides.
Yeah, not just two, all four of them. All four of those triangles are congruent by side, side, side. So by side, 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 the rhombus is divided into four congruent triangles. Let's make this point here in the middle E, where the diagonals cross. We'll call that point E. Okay? Then we can say angle AEB is congruent to angle AED So this angle is congruent to that angle. By what? How do I know that they're congruent? Somebody else? How do I know those two angles are congruent? We said the triangles are congruent, so how do I know the angles? Lily? Yeah, by CP. So those two are congruent by CP. What else is true about those two angles? They're congruent and what, Shatiz? Supplementary, right? They are also supplementary. What do we know about angles that are congruent and supplementary? Shatiz?
That they're going to be right angles.
Right. They're congruent and supplementary, so they are right. It follows then, yeah, that, if that's a right angle, then we know that AC is perpendicular to BD. Okay, any questions there? No questions there, okay. Theorem. If the diagonals of a parallelogram are perpendicular to each other, then the parallelogram is a rhombus. So if I apply that statement to this picture, it would say, if ABCD is a parallelogram with AC perpendicular to BD, then AB equals BC equals CD equals AD. We're going to prove it. We're given a parallelogram ABC with AC perpendicular to BD. We're going to prove that ABC is a rhombus. First step. Okay, I'm just going to call them people. So, the first step, AC is perpendicular to BD. How do I know that, Victoria?
Given.
That's given. Step 2. What do I know from the diagonals of a parallelogram bisect each other? Ellie. No. What statement can I, what segments, what can I say? Go ahead.
ABCD is a parallelogram.
No. Can't say it's a parallelogram. We already know it's a parallelogram. Steve.
We know that BE is congruent to DE and AE is congruent to CE.
Right. AE is equal to CE and BE equals DE. How do I know that triangle AED is congruent to AEB, is congruent to CED, which is congruent to CED? How would I know that? Caitlin? Nope. Look at the picture up above. It's marked in the picture up above. That's not side, side, side. We don't know. We don't know BC and AD are congruent. It'd heat you. SAS. Or what else? Chatice?
Leg.
Yeah. Leg. Or SAS. Either one. You don't have to put both. I'm putting both, but you could use either one. What would I say by CP? Zach, what would be the next thing to say by CP? Nina.
That BC is congruent to AD and that AD is congruent to BC.
You got part of it. We've got AB congruent to BC. What else? What else could we say? Zach? Yeah, all those are congruent. All the sides are congruent because all four of those triangles are congruent. So we'd have CD congruent to DA, and so on. All right. That's by CB. All right. ABCD is a rhombus. How do I know that? Ahitya. Definition of a rhombus. Okay. The diagonals of a rhombus A, B, C, D have lengths 6 and 8. Find the lengths of the sides of the rhombuses. Nick, how would we do that? Diagonals are 6 and 8. How would we find the lengths of the sides? You what? Don't have to do that. Chris? Yeah, Pythagorean theorem. Because he skipped a couple steps, but because that, okay, we know the diagonals, a couple things. We know the diagonals are perpendicular. It's a rhombus. And then we know the diagonals bisect each other. So the lengths of the side would be 3 and 4. Right? So then we have 3 squared plus 4 squared would equal to BC squared. So that's, 9 plus 16. It's a Pythagorean triple equals BC squared. So BC squared equals 25. BC equals 5. So the length of the side of BC would be 5. And all the lengths of the sides are the same. So we would have the length of the side is 5. Theorem. A parallelogram is a rhombus if and only if its diagonals bisect the opposite angles. So in this picture, parallelogram ABCD is a rhombus if and only if AC bisects angle A and C and BD bisects angle B and D. This is not true of all parallelograms. Just for a rhombus do the diagonals bisect the angles. We're going to do a proof of that, an informal proof.
I didn't marching band and I received an email saying that I was supposed to be released at 10.
Yep.
Be done.
Marching band, you're supposed to go to the pep session now. So yeah, if you're a marching band, you can go ahead and go. The homework is posted in Canvas. All right. All right. So in rhombus ABCD, we have to prove BC is congruent to angle BAC is congruent to angle BCA, and angle DBA is congruent to BDA. All right. So an informal proof of that. We've got, we could use the idea that the diagonals that bisect the angles, right? So we could say angle BAD. Okay, we start out with opposite angles are congruent. So we'd start out with angle BAD is congruent to angle DBC or DCB. We know that because the opposite angles in a rhombus are congruent. So we could say that 1/2 of BAD is equal to 1/2 of DCB, angle DCB, because, or we could say, angle BAC is equal to angle BCA, and that's because the diagonals bisect the angles. Alright, so we've got these two congruent to each other. In a similar manner, we could say angle DBA equals angle BDA. Alright, so that would be these two are congruent to each other. Alright, any questions? Yes.
Could you prove that angle BAC equals angle BCA by the isosceles triangle theorem?
Angle, say again, B what? BAD?
BAC and BCA.
BCA and BAC. Yeah, you could. Isosceles triangle theorem. Yeah. Yep. All right, so let's review the characteristics we learned today. Is that we've got in a rhombus, we've got, well, we know rhombuses are parallelogram. The diagonals are perpendicular to each other in a rhombus. We know that the diagonals bisect the opposite angles. And they would also have the characteristics of a parallelogram. The diagonals bisect each other, opposite angles congruent, diagonals form two congruent triangles, and so on. All right, that's the notes. Price. All right.